So, good morning to everybody and thanks for being here. My name is Iran Zurkola, I'm from Tecnalia and I am part of the MAtchUp project team. Today, in this webinar, in building up the strategy towards sustainability, we will present you how in the project we are doing to build up the strategy towards sustainability for our cities. This is part of a series of webinars we are doing in our project. Before starting, some rules to succeed in the webinar. First, please keep your microphones muted and your cameras switched off. Use the chat box to pose your questions. Remember that this webinar is being recorded and please enjoy it. Some minor notes about the project. MAtchUp project aims at strengthening the planning processes for urban transformation, consolidating the benefits of deploying large-scale demonstrations projects of innovative technologies in energy, mobility, and ICT sectors by means of substantially improved models for replication and upscaling based on impact evaluation, and ensuring in the same time the bankability of the solutions by means of innovative business models, which all leads to achieve real deployment further than the pilots carried out in the lighthouse cities. We are 28 partners in the consortium. We have 3 lighthouse cities, Valencia in Spain, Dresden in Germany, Antalya in Turkey, and also 4 follower cities, as well as several SMEs, industrial partners, and research centers. As mentioned before, the webinar today will be focused in this construction of the strategy towards the sustainability for the future of our cities. We will have 4 speakers. The first one, Íñigo Muñoz from Tecnalia. He will explain the energy process with a double bottom-up and top-down approach. Then Francesco Reda and Apo Wovila from BTT will expose the design, development, and evaluation of positive energy districts. Then Nora Sendner from the city of Dresden will explain the update and upscale actions on the SECAP. And finally, we will have some minutes for questions and answers. So that let's start. Íñigo, the floor is yours.
Okay, thank you very much, Iranchu, and thank you very much all of you for coming to this webinar. Sorry about the mask. Hopefully we will get rid of them, I hope soon. And well, my name is Íñigo Muñoz and I came from Tecnalia, and I will be glad to share our energy modeling process based on with a double top-down and bottom-up approach. So I will share my screen. Sorry. I think now can you see my screen?
Yes, perfect.
Okay, thank you. So I don't know if you see my presentation or.
Yes, we can see it.
Okay, so let's get a quick overview of the agenda of my presentation. So I will start with a short contextualization of the need of energy modeling in the urban environment. After that, I will present our methodology for the development of medium and long-term energy strategies and focused on the urban energy modeling and scenarios generation. I will illustrate it with some case studies from the MAtchUp project that we have found relevant, and I will end my presentation with some main conclusion of our work. So first of all, as you may already know, cities concentrate or gather around more than 50% of the global population. They concentrate almost 64% of the primary energy consumption around the globe and are the source of the 70% of the greenhouse gas emissions, energy-related emissions. So the expected increase of the urban population in the next years will put more pressure, more environmental pressure on these areas. So the decarbonization of cities is a must in order to achieve climate targets. So to face this challenge, the efficient management of available resources and energy planning must be a must. So energy modeling arises here as a powerful tool to support energy planning and policy making. Okay, so there is still a lack of, well, there is still a need of clear methodologies for urban energy modeling and in order to adapt current national energy models. So our methodology tries to simplify the energy modeling and scenario generation process in urban environments by combining the bottom-up and top-down approaches and by the build-up of straightforward scenarios. Sorry, by the straightforward build-up of energy scenarios. So the main goal of our methodology is to provide support to the municipalities in the definition of their medium and long-term energy transition plans by providing technical support in the energy characterization of the cities and in the prospective analysis of urban energy scenarios. We should give valuable information to the city stakeholders from which they can take decisions based on the results from these scenarios. So our modeling process is embedded in a broader methodology for advanced integrated urban energy planning, which have been developed in other smart city projects. So the methodology consists in 4 main phases, which go from the energy characterization of the city to the impact assessment of energy scenarios. So the first phase starts with the energy characterization of the end-use sectors of the city, with a special focus on the energy characterization of the building stock model using georeference data. The second phase deals with the energy modeling of urban energy systems and the generation of energy scenarios, which are constructed based on the evolution of the main socioeconomic drivers and implementation of energy interventions. The techno-economic analysis of these interventions is assessed in the third step of the methodology, where the supply chain of this intervention is assessed. The methodology ends with this step 4, in which the scenarios are assessed based on multi-criteria analysis. So the local stakeholders can decide which scenario should bet its necessities, its priorities. So I will focus on the first 2 steps of the methodology, which are focused on the energy modeling and scenario generation. So our modeling process starts with the energy characterization and energy modeling of the city's energy use and end-use sectors. So in this first step, we define the city's reference energy systems with with both demand and supply sides. So we integrate both top-down and bottom-up data. So the first one is issued from city database or energy and emission inventories, for example, from SECAP inventories, or maybe also we use aggregated real consumption data from energy facilities. Bottom-up data is more focused on micro-level data, more technical data such as efficiencies, vehicle mileage, building geometries or construction periods, building and vehicle stocks, and etc. The combination of both types of data allows us to further disaggregate our model. In the case of the building stock characterization, we make use of the NRCAD model, which is a GIS-based model which simulates the building stock energy demand based on cadastral data. So in this figure, you can see a short explanation on how we integrate both top-down aggregated data, so mainly field aggregated data by sector, which is used normally from SECAPs, and we combine this data with more technical parameters such the use, age, or height of the buildings, stock of vehicles, their fuel efficiency, mileage, etc., etc., in order to get a more detailed characterization of the city and also get more detailed results. So once the energy baseline of the city is set up, we start with the modeling of the city's energy scenarios. So our first question could be what these scenarios are intended for. So the scenarios provide a set of alternative context for exploring different ways that the future may unfold. So again, in these scenarios, we combine top-down and bottom-up data to model the different pathways that the city can face. The energy demand and generation of the city for the next decades are calculated using a top-down approach and is based on the analysis of the city's historical development and the evaluation of committed plans and current regulation. We also establish some correlations between the energy consumption and the socioeconomic drivers like population, GDP, added value, and so on. But I must say that in the case of the cities, this is a hard task because this kind of data is normally lacking. So we usually end relying on assumptions. On the other hand, in the bottom-up approach, we try to model the energy interventions by implementing efficiency improvements, for example, activity reduction or changes in the building stocks of vehicles, in the stocks, sorry, of buildings, vehicles, and energy devices like boilers and so on. I must say that in these scenarios, we include both the evolution of the demand side and supply side of the city. So two types of scenarios are built. The first one, the business as usual scenario, displays a conservative view of the evolution of the city system, where former trends are kept and already committed measures are included. This is our benchmark scenario against which the results from the alternative scenarios are compared. So the alternative scenarios, on the other hand, present a more groundbreaking or innovative visions of the city, where different futures can be assumed and the impact of additional measures and policies can be assessed. So the results of the implementation of additional measures in these scenarios are compared against the POW results and providing a measure of the improvements or savings that will be achieved by the city when implemented these additional measures or interventions. So this methodology has been used in the MAtchUp project. I will show now 3 brief examples from the city of Valencia, Dresden, and Kerala of the use that has been given to these scenarios. So in the 3 cases, the scenario supported the decision making regarding the update of the city's climate targets. So in the city of Valencia, for example, the alternative scenario presented the expected evolution of the city's new energy strategy roadmap. In the case of Dresden, for example, the energy scenario was used to explore an alternative trend focused on mobility and transport related policies instead of the electrification of the mobility. So, for example, fostering public transport or active mobility measures instead of the whole electrification of the vehicle stock. And finally, in the Kerala case, the alternative scenario modeled the city's the decarbonization of the district heating, and we saw that ambitious targets that the city want to explore. And finally, yes, the city stakeholders can take decisions based on these scenarios and generated city visions. Also, that these scenarios can help to the setup of ambitious but also realistic targets. And finally, the development of these scenarios support the decarbonization and transformation of urban areas into sustainable systems through the efficient management of available resources. So that's all for my part. Thank you very much, and I would be glad to ask your questions in the Q&A time. Thank you very much.
Okay, thank you, Francesco Reda and Apo Wovila, please, from BTT. Thank you.
Right. So, hello everyone. I'll have the pleasure to guide you through the design development, and then evaluation will be actually Apo, so taking you by hands of positive energy districts there. But let's then start immediately. So we're going to talk about the design. First of all, introducing what is a PED and how many PEDs actually can be. Then we'll go through some national and local boundary conditions that you may need to consider in your design, then touching a bit the development of PED, and finally concluding with evaluations of PED with KPIs. Just a side note, so this is actually a collaboration activities with the project Sparks, which is about PED. Okay. I won't talk about this project since time is actually not in our favor, so I will jump immediately to the point. So design of PED. First of all, what is a PED? So there are some definition around, but let's say and some of these definitions have something in common. What EU says that, or what EU sees as a PED is a district which have several buildings that actively manage their energy consumption and energy flow between them and also with the wider system. So you here starts to have a glimpse of what are the different pieces of the PED puzzle. So buildings that are able to exchange energy between them, but also being open to interact with an external system. The precondition, of course, the requirement is to have a positive energy balance, and here the definition actually then varies a bit. The most important thing is to have an annual energy balance. That's what the Commission actually says today. And then there is also a touch upon the different kind of solutions, technical solution that you may use, and they kind of support the use of advanced material, local res, and so forth. And finally, last but not least, is not a mere technical system, but actually users, so citizens and users should be in centers there as well, so involved. Then if we look at other definition, like for instance the one on the JPI or ERA, they go a bit more in detail on the requirements. So the PED should rely only on renewable energy, which in a way makes sense. It should also focus first on energy efficiency, so not just on the production side, but also on the demand side, trying to optimize and decrease the demand side using energy efficiency. And then another keyword, energy flexibility. So the provision of energy flexibility as a service as well, since there is the connection with the district and there are and additional functionalities that building can offer with their sensors and their intelligence and storage. So the flexibility comes also into play. This goes hand in hand by the adoption of renewable energy, because by the basically fluctuation of the generation, then focusing on flexibility, it then is a must then to avoid different mismatch. All in all, how many PEDs exist? So that's quite a debate among different initiatives on PEDs worldwide and also European-wide. So for instance, in ERA, so the European Energy Research Alliance, this is something that we have strongly debated, and we came up with 3 types of PEDs. We have the PED dynamic, autonomous, and virtual. What's the difference between them? So the autonomous PED is the condition to have an autonomous PED is an urban animal that has all the system, the generation system, storage system within their boundaries here. So here I'm touching also the boundary aspect. So all the energy that the district needs has to be produced internally. And when it comes to the balance, this is actually instantaneous balance. So to be an autonomous PED, you have to be covered for each instant of time your demand with energy produced within the boundaries. Then we have the dynamic PED, which has a more relaxed way with the interaction with the grid here, so that you can use the grid as a kind of ideal storage, and all the energy that you need has to be still produced with system within the boundaries, the physical boundaries of the district, but then you can have moment of time or period during the year where you produce more energy, of course, than you wish. You can put it into the grid. Then another period of time that you can actually you don't produce energy to cover your needs, and you can take ideally what you have given to the grid back. All in all, you have to respect, of course, the annual positive energy balance in both. Then the virtual PED, which is actually a more open concept today, which strongly then interact with the grid. So all the renewable energy generation to cover your demand could be also positioned outside your district there. You still have to acquire the positive energy, the annual positive energy balance. So in moment of time, with the renewable energy that are within the district, you need to export the energy also. But at the moment of time, you can use also external sources. So pro and cons of these 3 PEDs typology. The autonomous, of course, you go for self-sufficiency, but then of course more storage capacity may be needed for covering your demands. It's quite problematic for zone with high seasonality, so variation and during the seasons. So the dynamic PED is more flexible regarding system control, since you can use actually the grid as an ideal storage. And indeed, it does not require much storage capacity. And of course, it's dependent on external electricity or energy generation. The virtual one here you need to optimize your PED or the selection of renewable energy, looking also at what can be offered at the regional or national scale, and which gives you also more room to maneuver and also to reach the cost optimal in a different way than the other PEDs, of course. In this regard, since you rely so much on renewable energy outside your district, then an advanced energy distribution solution is needed, especially to then create this evidence-based transaction system for energy transaction that occur between buildings inside the district and renewable energy outside. But then to design a PED, so given now this very brief knowledge on the different PEDs and so forth, what are the aspects that you should look into it? Well, first of all, of course, is the climatic condition and the type of building, which will define more or less also the building demand there. So, and some of these by the climatics, by the location, of course, might be good advantage or not good advantage for different PEDs. So population, that's also another parameter. So if you have very dense area, then so most probably the demand, so the density of the demand will be also quite high in a district. So then the size of the renewable energy system, so the generation inside the district is of course affected by that. Then there is the capita. These urban animals are usually expensive, especially if you go for an autonomous one. And I will show actually what's the variation between them in a moment. So the GDP actually is a good indication also to look at, because the GDP, the more richer is the area, of course, the more you can afford that. On the other end, electricity price also is another thing for energy price in general to look at. The more expensive is the energy, so the more sense makes to have a kind of advanced PED. Other thing to look at is, of course, on the energy efficiency side. So on the energy demand, the level of insulation, so the level of demand for the buildings there, and also the policies. Or if the national or the country has specific policy when it comes to renewable, which of course is kind of facilitating the PED implementation. I'm going to show you an exercise that we did for a pre-design of a PED in the district of Kalasatama there. And you see here we have considered different energy solutions. And on the analysis we have done, you see actually that varying the capacity of the different technical system, you may achieve different PEDs. The autonomous PED is basically here on the blue line. On the black line, you actually see the cost. Of course, it's the most expensive one. But then if you look at the net energy balance, so the curve here, so the blue curve, then the imported electricity, you don't have imported electricity. Actually, this is actually on the positive side. So since you don't import any electricity from outside. Instead, from this place from this point to this point, you have a dynamic PED. So you still have above actually the net energy balance, if you look still at the blue line here, but you still require electricity from outside to cover your demand. The rest is exported then. And from this point on, then you have the virtual PED. Here. So all in all, you see that autonomous is quite expensive. So when you consider to go for it, then you have to carefully also look at the investment and so forth. And the dynamic gives you a more wider spectrum there of possibilities. So the takeovers, the PED concept can actually vary depending on the location, as we saw. So the different parameter that plays and give you the boundary condition to play with. Regulation, also something that you have to look into it, and you have to look also into economics and resource available, so in the surrounding of the city, and land use is also another point. An holistic approach is anyhow needed. So first of all, you need to understand, looking at the resources available within the cities and in the region as well, what are the technologies that you can actually use over there, and start to have an understanding of what's the technical concept there. And finally, once the concept is endorsed, then also regulation and can be endorsed by regulation and policy at the country level. So you may also choose different technologies or different solutions because the regulation actually direct you to a different settings. When it comes to development, one thing is a technical development that I show you also with the exercise for the optimization exercise. But at some point, things becomes very practical. So you may select the ideal solutions by looking at the different parameters or climatic parameter, economic and availability of sources and so forth. But in the end, you need to look at the local ecosystem. Because at some point you would need maintenance, you would need an ecosystem that is able to create service on top of these technologies as well, so to get revenues and so forth. So you would need quite a live local and innovation ecosystem. Another thing, since here we're going from the conventional approach or in the energy sectors, producing energy in a central way, we are going here in a kind of very decentralized approach. We're having renewable energy generation and storage within the district. Some of it, depending on the PED typology you go for it, can be also outside the district. So then the governance is actually quite different than before. And planning instruments also need to reflect these advanced capabilities and then advanced functionalities there. And all in all, the co-creation is something key in this particular case, since citizens have to play a role, or user of building will have to play a role to offer demand-side management capabilities, but also in selection perhaps of different technologies. Technical engineer might select one technologies that somehow people don't perceive it very well, so they won't accept it. So in the end, they should be also somehow involved into this design process. I'll stop myself here and then leave the floor to my colleague Apo for the evaluation part.
Yeah, thanks, Francisco. Hello, everyone. So yeah, I will conclude this presentation with a couple of words on ongoing work related to evaluation of PEDs. Of course, this is a question very much related to the definition of PEDs that Francisco was explaining. Then how we evaluate the performance of PEDs, but on the other hand, it can be also a good way to concretize what we mean by PEDs to define KPIs. So then they really show what we want to show, what we mean by that. So we quite often tend to think only about environmental, technical aspects. So that probably also comes from the name, like about the positive energy balance. But of course, it's very crucial that we have this holistic approach in the development and evaluation of PEDs, as Francisco explained, so that we make sure that the solutions are also economically viable and socially desirable, because otherwise the PEDs will not be successful. So Francisco, please, next slide. So looking at the work on defining KPIs to evaluate PEDs, yeah, so there is not yet a kind of much harmonization, also due to these differences in the definitions. But of course, one of the crucial indicators is related to the main, like the energy balance, and that can be at annual level. So there are work on like indicators like on-site energy ratio that then shows like the balance between the renewable energy supply and the demand at annual level. Of course, then what type of renewables are included and so on, that relates to the definition that we use. But of course, due to the variety in the supply of renewables, wind and solar, it's then very important to look at the short-term balance also between the renewable energy supply and demand. So there are many mismatch indicators that then look at this short-term balance. There is less work or less let's say harmonization in terms of economic and social KPIs. There are course many available from other initiatives, but I think they would deserve more attention and also more discussion to try to align these approaches for the holistic evaluation. So as I said, there is still lack of harmonization, and that's kind of what we try to tackle in MAtchUp. What is our main contribution to this discussion? Because as you probably know, MAtchUp is a part of a family of 18 smart city lighthouse projects that are quite similar in many aspects. So they are collaborating in certain topics, and we are leading the collaborative activities in terms of monitoring and evaluation with the other projects. And there we have also collaborated with this IEA annex on positive energy districts, and we are preparing a workshop for October to discuss what type of common KPIs should be used for the evaluation of PEDs. Thanks for your attention. So we will remain here with Francesco for any questions at the end of the webinar.
Yeah, thanks also from my side. Looking forward for your questions.
Okay, thank you very much. Nora Sendner from the city of Dresden, when you want. The floor is yours.
So my name is Nora Zentner. I work in the climate protection unit of the city of Dresden, and I'm responsible for the climate protection concept and the CO2 balance of the city. Today I would like to share with you our process of updating the integrated climate and energy. The climate protection plan. I will start with a short overview of the historical development of our concepts and give you a short insight into the update process, and finally we'll show you where we are at the moment. So to start, regarding the SECAP in Dresden, we've been joining the Covenant of Mayors in 2016. And it's a little, maybe typical for different municipalities that we have different organizations regarding those themes. So we, the climate protection unit, are responsible for the climate protection plan, and the unit of the environmental agency is responsible for the adaptation plan. These plans have been developed before we joined the Covenant of Mayors and are almost 10 years old. Now we are updating both plans. We are updating our climate protection plan until summer 2022, and we're now already in the process. And the climate change adaptation plan is also updated until 2022. And we will, of course, consider different interactions between those plans. And also, I would like to give you a link between the MAtchUp project and our SECAP. With the implementation of the MAtchUp actions, CO2 savings regarding the buildings and city infrastructures and transport can support our new set goals. And the MAtchUp supports also the update of the climate change adaptation plan by initiating the process of a new set climate adaptation plan CAP. And also the upscaling plan for demo actions to other locations are, oh, my screen is cut off, I'm sorry. I don't know how to, okay, so sorry. It's ongoing, and goals regarding the SEAP and the CAP are included. So on the next slide, you see the differing targets within different regions, and also how those targets are developed in time. The greenhouse gas reduction targets have been adapted in the past years due to more ambitious goals. In Dresden, we have our, let's call it existing target from our climate protection plan. This you can see in this number. It's from 2013, and this target is already more ambitious than those targets that were set by the European Union and also from Germany. And we will also have a new target with our update, and we are also there more ambitious than those now existing goals regarding the climate neutrality. So the history of our action plan. Our action plan was developed between 2011 and 2013 with the help of an external service provider and approved by our city council in 2013. The climate protection target, as you have been shown in the slide before, consisted of reducing emissions by 10% every 5 years, starting from 2005 until 2030. The effectiveness of the measures were checked annually by means of resolution controls, and the CO2 balance was also intended to show whether the measures were leading to a reduction in greenhouse gas emissions. But like you can see in this chart, the emissions have stagnated in recent years, so our intermediate goals have not been reached. Therefore, the City Council decided to continue the concept and call the new target. And the new target is achieving climate neutrality well before 2050. And also, the update means a new momentum for climate protection within our city. So, since we needed the support of a third party for the legally, oh no, I'm sorry, I'm just skipped something. The Climate Protection Unit has been preparing this decision to update the concept for almost 3 years. Also, it was finding in the MAtchUp project. Therefore, we were able to prepare the tender just a few weeks after the City Council's decision, which would take more time in another case. Since we needed the support of a third party for the legally compliant awarding of the services to a contractor, and the process for commissioning took almost a year. Since we did not know whether the threshold values would be exceeded in the tender, we conducted a European-wide tender from the very beginning. Although an European procurement process is complicated anyway, the Corona pandemic has added additional stumbling blocks for us. We had the first digital tendering interview with our city with 4 potential contractors. And in December 2020, we signed the contract with our external partners. On the next slide, you can see the core elements to be considered in the update. We are looking not only for a concept, but above all for an action plan to which many partners feel committed. Since climate protection cannot be achieved by one municipality alone, we have planned a comprehensive participation process that will help us gain many allies to implement the climate protection goals. Of course, we need to show a scenario how to achieve the climate protection target for 2030 and before 2050. Since the current action plan does not provide for sufficiently structured and systematic controlling of the measures, we also need an update on the monitoring process of achievements towards the interim targets and overall objectives. The city of Dresden as the client develops the concept in cooperation with the contractor. And in addition to the technical development, there's also input from boards that we have set up specifically for the process. These boards are an advisory board of scientists and a round table with various representatives from politics, business, and the public. And also we have it's called climate forums and interviews with other partners that will help us get information we need. So on the next slide, you see the important steps for the time frame. We are obliged to finalize the action plan in summer 2022 and submit it to the City Council. An important step we have almost reached is the definition of the target corridor for the climate neutrality. We are already in this part, and now we need to build on this and develop measures and projects and evaluate also the impact and the strategies towards the target. Alongside the conceptual work, we have planned a participation process also for the public. And the first steps are interviews with different stakeholders and their view on climate protection measurements and projects. And these discussions will help us to define obstacles and find ways to overcome those in the future. Also, the public will be involved with 2 climate forums. You can see here in summer and also in beginning of next year. That was called implementation. So we really want to step from the concept phase to a real implementation of measures. Another format will be different workshops for bringing together different stakeholders on special topics. And we also have planned an online tool where the public can provide us with ideas and projects from their side. So the climate protection plan will have several action fields. These are the efficiency of residential buildings and industrial buildings, district development, integration of renewable energy sources in power production and district heating, centralized and decentralized, climate-friendly mobility, and also organizational and structural transformation, which is really important, and also reducing the non-energetic greenhouse gas emissions. And within these fields of actions, there will be many different measures and projects that are listed within these. So where are we now? Since we are currently in the process of working on the update, I would like to conclude by giving you an overview of the steps we have achieved to this date. We have been defining the framework for activities and a draft version of our measurements portfolio. We started the analysis of potentials. We have a suggestion for the definition of climate neutrality. We are following the what's called I don't know. Yeah, we will go with the CO2 budget. And we also started a stakeholder participation process with technical discussions with companies and also the public participation, which will start in July. And finally, I would like to conclude with a comment on how we understand the update of the action plan. We see it as an ongoing process. Even after finishing the concept, we need to continuously adapt the action plans. So that's it from my side, and I hope I did not exceed the time frame. So I would like to give to Iranzu, I don't know.
Yeah, thank you very much for the presentations. Now it's time for questions. I guess you can see my screen. Okay, so let's start. First question is for Inigo. Could you please give us some more details on the NRCAD model, for example?
Yes, thank you for your question. So the NRCAD model is a tool developed here in Tecnalia. It's a GIS-based tool for the energy and environmental simulation of the city's building stock. So it's based on cadastral data such as the geometry, height, construction period, geometry of the buildings, and can also be complemented by other data such real consumption data from energy utilities or energy labels, for example. So it performs the hourly simulation of the energy demand of the buildings and can also be used for generating scenarios and also to assess the implementation potential of renewable solutions in buildings. So regarding the relation with our urban planning methodology, we use this tool to disaggregate the building stock information and to give more detail to this sector, so to the residential and service buildings sector. And we combine this information with the rest of end-use sectors of the city, such as, for example, industrial of transport sector, in order to simulate the whole city energy scenarios.
Mm-hmm. Okay, thank you very much. Really interesting, this too. One more question for Francesco and Apo. Okay, what is the role of the city authorities in the development of these positive energy districts, and how it should be taken into account in this city planning that the cities need for facing this new energy transition? I don't know, Francesco, Apo.
I can take it.
Yeah.
Absolutely. So thanks for the question. Well, city has a kind of a primary role. It has to basically lead the ecosystem. And we're talking about a new urban animal that is still under the light of the research. So the regulations are usually not in line with all the functionalities and requirements that a PED should have. So then city authorities have this kind of role as a guarantee, in a way, for all the involved players, building developers or technology providers that have to go a bit somehow borderline with the regulation as well. And sometimes also city has to change their local regulation when it comes to energy transaction between buildings there. Plotting assignment might be an issue and so forth, and that's to give me the opportunity to connect to the other part of the question about the planning. So when you plan an area, then you need to bear in mind what are the requirements for PED, because there are some limitations that usually also in the plot assignment or on the other sectors like transportation and so forth, so the city should change. We had some hands-on experience with our PED districts in the project that focused on PED, where cities have to somehow come up with a smart approach to assign the plot, because in the regulation that we have here, one point was that you weren't allowed to exchange energy between buildings if they don't formally belong to the same plot. Otherwise, you have to involve the DSO and other partners there. So they come up with a new plotting structure or procedure called the 3D plotting, so that in a way they were able to assign the plotter as he was one, but then dividing it inside this kind of unique plot in a way. It was all in all a kind of a desk so measures, but sometimes those issues can actually jeopardize the deployment of those technologies. So.
Okay, thank you very much, Francesco, for your clear answer. And one last question for Nora. Which are the biggest challenges you have been facing, or maybe you are still facing in the updating of this action plan, this SECAP?
Yeah, thank you for the question. The biggest challenge in adapting the concept is the integration of very different focal points at different levels. As a municipality, we are not self-sufficient, but embedded in context of regional and global interdependency. And therefore, we can benefit from other climate protection activities outside our territory, but at the same time are also very dependent on and rapid progress being made at a higher level. And we can only influence what is within our focal scope, local scope of action, and we will focus on that in our concept.
Okay, so time is over. So thank you very much to all of you for your attention, for being here, and hope we will see you in next webinars. Okay, so thank you very much and have a nice day. Bye bye.